In this video, we're going to look at differentiating when we have the product of two functions using something called the product rule. Now, our product rule states that if y is equal to uv, in other words, two functions multiplied together, then dy by dx is equal to u dv by dx plus v du by dx. So looking through our first example here, we're being asked to differentiate y equals x squared e to the 3x with respect to x. And we can spot that we need the product rule because we have x squared and e to the 3x, two separate functions just being multiplied together. So I'm going to let u equal x squared and v equal e to the 3x. So u is x squared, v is equal to e to the 3x. And then if I differentiate each of these, du by dx is equal to 2x, and dv by dx is equal to 3e to the 3x. So then, to differentiate this and find dy by dx, we just need to do u dv by dx plus v du by dx. So u dv by dx is going to be x squared multiplied by 3e to the 3x. So 3x squared e to the 3x. And then v du by dx is just going to be 2x times e to the 3x. So 2x e to the 3x. And that's going to give us our answer. We can spot that we do have some similar terms in both of those terms. So we're just going to factorize that. I've got x e to the 3x as a common factor. So x e to the 3x, lots of 3x plus 2. And either of these forms is correct, depending on how they ask you the question. This and this, both of these are fine. The second question, we're being asked to differentiate y equals 2x, lots of 1 plus 3x to the power of 5. So we can say that it's a product because I've got 2x being multiplied by 1 plus 3x to the 5. I'm going to let u equal to 2x and v equal to 1 plus 3x to the power of 5. Now du by dx is just going to be equal to 2. dv by dx is a little trickier because we have a function of a function. So with our function of a function, we're going to use the chain rule. So within this, I'm just going to use the chain rule. So we're going to let u equal 1 plus 3x, and therefore I'm just going to use y here because it's what we're used to. So y is equal to u to the power of 5. du by dx, differentiating that, just gives us 3, and dy by du gives us 5u to the power of 4, which of course is 5 lots of 1 plus 3x to the power of 4. Therefore, dy by dx, so differentiating this, would give us 3 times 5 is 15, lots of 1 plus 3x to the power of 4. So dv by dx is equal to 15 lots of 1 plus 3x to the power of 4. We've just used our chain rule there to help us to differentiate that term, and now we're going to go back to our product rule. So dy by dx is equal to u dv by dx. So 2x times 15 is 30x. So I've got 30x lots of 1 plus 3x to the power of 4 plus v du by dx. So I've got 2 lots of 1 plus 3x to the power of 5. Now that there is absolutely fine as a correct answer. Depending on how we're asked the question, we may be asked to factorise, to simplify that. So just to finish off, we are just going to factorise that. Now I've got 2 as a numerical common factor for these, and I've also got 1 plus 3x to the power of 4 as a common factor. There's a power of 5 there, but there's at least 4 in both of these. So I can write 2 lots of 1 plus 3 For more GCSE and A-level maths content, subscribe to N Jackson Maths on YouTube.